Today we will discuss the methods of ventilation of electrical machines. Cooling of an electrical machine with the help of a stream of air is known as ventilation. So ventilation of machines are classified into different types according to the scheme of ventilation. First type is open circuit ventilation, then closed circuit ventilation, then surface ventilation. This classification is based on the scheme of ventilation. There is another classification that we will discuss later. Then first one is open circuit ventilation. Open circuit ventilation means the heat is given up directly to the cooling air and the air is being continuously replaced. That is known as open circuit ventilation. It is again classified into two: induced ventilation and forced ventilation. Induced ventilation is as shown in figure. In this case, this figure shows the cross section of an electrical machine with induced ventilation. Here, the a fan is provided on the shaft of the machine, and when the machine rotates, the fan also rotates, and the fan produces a reduction in air pressure inside the machine. Reduction in pressure inside the machine. So, with the help of that reduction in air pressure, the fresh air comes into the machine through air inlet. Fresh air comes into the machine through the air inlet, and at the same time the hot air will be passed to the atmosphere, pushed to the atmosphere through the air outlet. That is known as induced ventilation. Then the other one is forced ventilation. In this case, again a fan will be provided, and the function of this fan is to suck the fresh air from atmosphere. So the hot air will be pushed to the atmosphere. That's how the forced ventilation happens. Then the second category is closed circuit ventilation. In this system, the heat is transferred through an intermediate medium, such as air or hydrogen, any other gas. Such a type of ventilation is known as closed circuit ventilation. So in such systems, there will be a machine which is to be cooled and a cooler which provides ventilating medium to the machine. And the last one is surface ventilation. In this case, the heat is transferred from the inside of the machine by cooling medium to the external surface of a totally enclosed machine. So, surface ventilation is used for totally enclosed machines. So, the external surface is being cooled by natural means or any other methods, such as additional fan provided for the machine. So that's all about the classification of methods of ventilation. This is another classification of ventilating systems. This classification is based on how the cooling ducts are provided for the machine. So there are four types: radial, axial, combined radial and axial. First one is radial ventilating system. In this case, the ventilating air will be passed radially, and in the case of machines with longer core lengths, radial ventilating ducts will be provided through the core of the machine, stator core as well as rotor core. And this is a very effective method because as the machine rotates, the centrifugal forces will help ventilation. And the next one is axial ventilating system. In this case, the ventilating air or ventilating medium will be passing through the machine axially. So, such a system is used in machines which are having very high speed. So the provision of radial ventilating ducts will not be possible. In such cases, axial ventilating system is provided, and in order to improve the ventilation, the core plates will be punched with holes so that air can be passed very easily through that holes. Next one is combined radial and axial ventilating system. Such a system is used for large machines or large motors and small turbo alternators. This is a combination of radial and axial ventilating system. So, in such a system, the air is drawn into the machine from one end and is passed through the ducts. So as we can see, the air passes axially as well as radially. So that's why it is a combination of radial and axial ventilating systems. Next one is multiple inlet system. Such a system is always used for a machine with very long core. If the core length is high, then we can use multiple inlet system. So normally it is used for turbo alternators with a long core. This is used because it is difficult to supply required amount of cooling air to the central parts. If the core is very long, the core is very long, then the central parts will be hot as compared to the ends. So if you have to provide equal amount of cooling air for the central parts, then we have to provide multiple inlets for the cooling air. So such a system is used for machines with long cores. Thank you.